Hey everyone, thanks for coming. And you might notice my voice is a little bit hoarse. I've been sick, so we'll see how well my voice holds up. So this tutorial is kind of similar to ones I've done in years past. It's shorter. There is a GitHub link on this page you can see, and that it has all of the source for the slides that I'm doing. The slides run entirely within a console application, so you can get the source code and everything. We have the code for this talk has 6 modules, which I've tried to trim down for the time. We will do at most 5 of the modules. So the 6th module is about ORM relationships, which are a big topic. So if you want to go later to the GitHub, you can see chapter 6. And also I'm pretty much reading bullets and hopefully embellishing. So you can see everything later. If I talk too fast or something, everything's later. So SQLAlchemy 2.0 is this big release that I've been working on, and myself and others have been working on for quite a while. So we'll do a quick intro to what is SQLAlchemy. And the tutorial is going to also kind of include, it's going to be kind of focused on some specific SQLAlchemy 2.0 kinds of concepts. So SQLAlchemy is always referred to itself as a database toolkit. It's on the homepage. And the idea is to provide a lot of tools for databases. And one of these tools is an object relational mapper, or ORM for short. But there's a lot of other features in SQLAlchemy that don't use the ORM. So those features include things like a facade around the Python database API, which is the Python DB API is PEP 249. So SQLAlchemy's facade provides a richer kind of embellishment on top of the Python DB API. Database schema management functions so that you can create tables and databases and create schemas and things like that. SQL query builder, use Python expressions to build objects that become SQL statements. Schema inspection. So if you have a database, you can point SQLAlchemy at it and get a list of all the tables, columns, data types, constraints. All of those features, oh, that's my phone. All those features that aren't ORM are called SQLAlchemy core. So the main point is that SQLAlchemy has 2 kind of sections. There is the core, and then there's the ORM, which is built on top of the core. So most of this talk is going to talk about core, because for SQLAlchemy 2.0, the foundations are kind of in core. And there's an ORM thing you'll see. Sorry, I should just get to the slides. The tutorial which follows is the latest version of a similar tutorial I've been doing since 2007. Introduction on foundational concepts given in 2.0 terms. If you're new to this stuff, I don't know how many people on the talk here are people that have used SQLAlchemy for a long time, and other people like, what is this thing? Let me go to this talk, see what it is. The best prerequisite to follow what I'm saying would be that you know some Python. General Python programming would be good. Basic OOP, like if you know what a class and an instance is, would help. You kind of know some SQL, like with a select, insert, you know how to create table, things like that. If you don't know SQL, SQLAlchemy is philosophically very oriented around you know SQL and you're automating your use of SQL, so it's not that easy if you don't know SQL first. And if you know what a transaction is, that would be great. So first up, some ridiculously important links for the new docs. We're trying to make the docs findable. People complain they can't find docs. So here's the most important links, and you can go to the GitHub and see these links. The main docs at docs.sqlalchemy.org. There's a thing called a quick start, which is like a 1-page, show me what this looks like. Then there's the unified tutorial, which is long and worth it, you know, to really introduce you to every concept you would need. And the ORM querying guide has got a lot of the new patterns for writing queries using 2.0 style. Now that's the first thing, so I'll go back to the menu of other modules. So those are the modules. So before we build a lot of things, we're going to talk about this thing called the engine. The innermost data connected to the database structure is called the engine, and it's the most foundational construct in SQLAlchemy core. You want to get an engine, you call a function called create engine. So this is some code, and code runs in here. So this is pretty cool. You'll see bulletin code, just mix and match. From SQLAlchemy, import the create engine function, and then we create this engine given a URL to a SQLite database. The single argument that create engine requires is a string or other kind of URL object that points to the database you want to connect to. The first part of it, the scheme with the : / is the database you want to connect to, the kind of database. And then following that are things like the host name and passwords and database name. When you do SQLite without any arguments, without any file name, you get this thing called an in-memory Python database. So it's a database that's only in the Python process and it's nowhere else. And it's very handy for tutorials because it doesn't have to have any file anywhere. But if you go to the docs, there'll be many other styles of URL that you can look at. So we made an engine above that will connect to a SQLite memory database. Nothing actually happened yet. It didn't connect. The engine's a factory that makes new connections when used. I'm going to close this because my dog is playing outside. And then this gets tangled. The engine also stores a connection pool, which is where connections will be reused for subsequent operations. So the engine doesn't connect till we tell it to for the first time. When we use the engine directly, we get a connection using the .connect method that will actually create a SQLite connection and do stuff with it for us. So right here, connection equals engine.connect. So what just happened there? So this is when we actually did connect to SQLite and we made a little in-memory database. The returned object is an instance of SQLAlchemy .engine.connection. And that's what that looks like. And then what the connection does is it's a so-called proxy for a DB API connection. Now, I'm using the word connection a little confusingly. SQLAlchemy has connection. That's what you deal with. Then inside of it is the Python SQLite connection that you don't have to worry about at all. But if you use SQLAlchemy, you should know as the programmer that it's there. And that when you have a connection that actually has a one-to-one correspondence to a database actual connection. So in this case, it's using Python's built-in SQLite 3 module. We can see it by peeking at the driver, the .connection.driver connection attribute. And there it is. That's the SQLite 3 connection. So that's the proxy for the connection. What can we do with it? The main thing you want to do with connection is to use the execute method that runs queries. And that will then do the stuff with the SQLite connection, which involves using an object called a cursor to run a statement and get results back. And when we want to run a textual statement, when we do these tutorials, I start with textual statements, like just select star from table or whatever. You use a construct called text. And so at the basic level, you can just make a string that select anything. So here we're doing a select. That's not from a table, just some arbitrary data. So select hello world. Just give us back that string. And then name it after a column called greeting. And then we run connection.execute statement. We get back a result. And when I press return, it'll run this code. So here's an actual statement running. This logging is SQLAlchemy's logging, and the tutorial slide runner has turned it on so you can see it. And the first thing that happens, you see this begin implicit, which doesn't mean SQLAlchemy did it begin. It means that the Python database API did it begin. Python database API includes begin in all cases because it does not use auto commit by default. So there's always a begin that the Python driver does. So SQLAlchemy has a log that says to you, hey, by the way, this is when we're considering the DB API to have done its begin. So you should know that it's there. And then we have our statement. And then we have some stuff about the SQL caching system that's new in SQLAlchemy 1.4, some stats. We can ignore that for now. And then we have an empty parameter list because we didn't set any parameters. Is anyone confused yet, or is this fairly easy old hat? If anyone has any, like, I have no idea what you're talking about, chime in or whatever. Okay. Connection execute always returns what's called a SQLAlchemy result object. In this specific case, it's a class called cursor result, which means it proxies a DB API cursor. We can see it there. That's the result object. And similar to a DB API cursor, which has methods like fetch all and fetch one for fetching rows, right? I'm going to fetch rows, but result has more methods, fancy things, nice things that are useful. More than previous SQLAlchemy releases. Prior to SQLAlchemy 1.4, the result was very basic, and now it has more stuff. One method it has that we'll use a lot here for demonstration purposes is called .first, which will return the first row of the result. And if there's no row, it'll return none. And then it closes the result set, which means it's going to close the underlying cursor. That's part of the database resources we have checked out. So we want that to happen. So let's get one row back and then close the result, because we only had a statement that had one row. That's a SQLAlchemy row object. And it looks and acts mostly like a named tuple. So we see here, it looks like a tuple. It has integer index. It's named tuple, which means it has attributes on it that match the column names. So when we did that statement, we said select hello world as greeting. The name greeting is here as a column we can access. Now, if you have the name greeting as a string, there's a dictionary interface on row called dot mapping, underscore mapping. The underscore is because name tuples, you want to leave the namespace open for dynamic attribute names. So use underscores for other names. Row dot mapping and use the string greeting, get the same data. This row object is not the same as it was in SQLAlchemy 1.3. And previously in 1.4, we introduced the new row, but it was an opt-in. And now in SQLAlchemy 2.0, it's the default row. That is a name tuple by default, acts like a tuple. And then if you want it to act like a dictionary where object in collection gives you a Boolean for the keys, that's the dictionary keys on mapping. So some quick, I'll call it a quick slide. Get lots of rows back at once. What's the best pattern? Iterate for row and result. Give me the rows. To get the rows back and assign the columns to variables, use tuple assignment for ID, greeting, comma, XYZ in result. As you iterate the rows, it will assign things to the variables. Using Python F strings to print is pretty nice. That's obviously whatever you do with the data. Iterate through just the first column of each row. We'll see this method a lot. This is called scalars. Scalars can transform the result to give you a new kind of result called a scalar result that gives you just one Python value, no more rows, gives you just the value. So that'll give you just for greeting and result to scalars, hello world, whatever. Get all the rows in a list called .all. That gives you the list. If you want scalars in a list, you call .scalars.all. This line shows us something new, which is that the result has multiple transformative steps that you can call. So there's all kinds of methods you can call that will change what it's going to return, and then you can actually get the rows after that. So it's a rich object. It's great. And that's the result intro. Some water for that. So we've got this connection. The next thing to know about it is it has a .close method. Now, what does that do? It doesn't actually close the database connection. It's going to release the database connection back to the connection pool, usually. Releases means the pool may hold on to the connection or close it if it's part of what we call overflow. When we use a SQLite memory database, there's a very special kind of connection pool called the singleton pool that has just the one connection, because a SQLite memory connection is normally, unless you do some very strange things, not shareable among multiple connections. If you want to talk to that database and the data in it, you've got to use that one exact connection. That's not how most databases work. Like SQLite file databases, you can have multiple connections to the file at once, and obviously all other databases have lots of connections, but SQLite memory is special, so releasing the connection to the pool won't really do anything except store it. When we call .close, you will see in the logging, if you're doing logging, the rollback, and that's because the Python database API, as mentioned before, implicitly begins a transaction as soon as you made any commands on it. So if you want this connection to go back to the connection pool where it could be sitting for hours, if you have a web application sitting there idle, you want to roll back the transaction. So you'll always see that rollback happen. The internal SQLAlchemy term for that is called reset on return. And that's the default that it does. There's ways to change it if you have special situations going on, but you're going to see that rollback. So that's the .close method. And after I show you that method, I'm going to say now, I don't want you to ever use the close method because I want you to use Python context managers. Python context managers are very good for when you have some kind of resource that is open, like a file or something, a file handle or a socket handle. You want to work with it, and you want to make sure it's closed when you're done with it. So that's the Python context manager pattern, which starts with the with statement. SQLAlchemy 2.0 should let you use context managers as much as possible. So when you connect to a database with engine.connect, as I've just shown, don't call close, go with engine.connect, and you get the connection back. And then in the block, do the work with the connection. If you have like a lot of work to do with the connection, call a function and pass the connection to it. But the point is, when you deal with SQLAlchemy objects and database objects, you want to make sure when you get a resource, you open something, you start something, you have a plan for that thing to be released correctly right there, because that's where all of our problems come, all of our but a lot of user questions, they have their sessions or connections being shared among many threads. They're global, no good. Their transactions aren't being closed, stuff like that. So when we do this context manager, we see the begin, as we've seen, we see the select of our statement, we see the results because I'm printing it, and we see the rollback, and it's all encapsulated in one shot. So context managers are good. And with that, we get into some more patterns with engines, and what we do here actually applies to ORM stuff. And it's important because this is stuff that people get wrong, and that's why I'm emphasizing it, which is SQLAlchemy always assumes there's some kind of a transaction at the start of SQL operations. Even if you use the database in what's called auto commit mode, which is very well supported in SQLAlchemy, SQLAlchemy from the client side still assumes there's some kind of begin commit thing happening, even if there's not really one, because that dictates how you write your program. And it dictates that you write your program in terms of where the beginning of something important starts, and where the ending of that important thing is. And it's good to write your program in that way, and SQLAlchemy wants you to do that. So for transactions, it wants you to, if you have a transaction, it's never going to commit for you automatically. And that's different. SQLAlchemy 1.4 and previous have an auto commit library level feature that commits things. That's removed in SQLAlchemy 2 because it was not really helping anybody. But it does mean that when we have released 2.0, we've had a bunch of people saying, hey, I have all these inserts and they're not getting committed, that they're not in the database. Why? They don't say it's not getting committed because they don't know about commit. They're like, I run a bunch of inserts and there's nothing in the database. That's what they'll say. And it's like, well, you didn't commit. That's a new thing in 2.0. Here's the migration docs. You have to commit. Or use an instruction that says, hey, run this block and commit at the end. So here are those two styles. There is also driver level auto commit, which we're not going to cover here, but you can do that too, which you will have to for some particular use cases. The connection has two variations in how to do this transaction. One is called commit as you go. You do engine.connect, and then you run some statements, and then you do connection.commit if you have to commit changes. If you're running selects, you don't have to commit. But if you're running inserts, updates, deletes, create tables, you want to commit. So here's a block where the engine.connect is connection. Run a statement to create a table, run an insert some data. This I'll show later. This is how to use bound parameters with a statement. We'll get into that in the next chapter. And then connection.commit. So add the stuff inside the block, commit, and then I can run more statements afterwards and commit those. So it's commit as you go. It's kind of how the Python DB API itself works. So we see if I run that code, the begin, some statements, and a commit. That's the important part. The other style is called begin once. And this is when you really have a bunch of statements and you want to commit them, and you definitely want to just run the one transaction. You can say, instead of saying engine.connect, you could say engine.begin. And that will say with engine.begin as connection. So that means check out a connection like we did with connect, and then also begin a transaction. And then on that statement, run run on that connection, run a statement, or run many statements. And then when the block ends, you'll see the commit, and the connection will be returned like that. Engine.connect can also be used with connection.begin. So you can have two separate blocks. So you can say engine.connect, and then within the engine.connect, you can do connection.begin. And that gives you a block that'll do, and you can run multiple blocks like these inside. like that. And that's the basics of engines and running textual statements. Are there any questions with that so far? I'm assuming none. I have the chat open, and if there's anything in Slack, they'll let me know. Okay. Nothing in the Slack. Okay. All right, chapter 2, table metadata. So now that we know how to talk to a database and how to send statements, we need to have something set up to be able to send statements that are more interesting, statements that involve tables in the database. And we use this thing called table metadata, which means they're Python structures that represent what the shape of a certain kind of table in the database looks like. SQLAlchemy provides this API first and foremost for decades using a well-known object called table. And it looks like this. So if older SQLAlchemy tutorials and actually our current tutorials will show you this table. This is a table for user account. So it's made to look a lot like a DDL create table statement. We import some imports and we do table and we make a string for the table name. Metadata is a collection that stores a bunch of table objects, and we create that up here as an empty collection. And then as you make tables, you pass this collection to it. And then you name your columns in the table. And so it's designed to look very intuitively like a create table statement. So you have column has a name, each column has a data type, and then it has optional constraints like this is the primary key. This column is part of the primary key. This column is not null. So that's table, and people have used SQLAlchemy have all seen this. This is very well known. And what I'm going to do is just move off of it for this tutorial. We're going to go out the side entrance and go somewhere else. So in real world use, most applications are using the ORM to a greater or lesser degree. Even if they're a core only application, there's probably ORM code in there. When you do ORM, there's no auto commit, but isn't begin similar? Well, yeah. So the question is, there's no auto commit, but isn't begin similar. So auto commit means that every time you run a statement, you run insert. The minute you send the insert to the database commits it. And then you run another insert, and that commits also. So auto commit means that every statement commits at one at a time. So that means if you run 5 statements, and the first 2 go in with no problem, and the third one throws an error, and your program crashes or whatever, the first 2 rows will have gone into the database, and the second 3 will have not gone in. So you didn't actually run a transaction. So the thing that we get from the main thing that the most obvious thing that we get from a transaction is called atomicity. It's the first letter in ACID, and that means that you can run a whole bunch of statements that will either go all in together or not at all. So auto commit explicitly means that you are not getting atomicity. It means you're getting one statement at a time. So SQLAlchemy doesn't orient itself around that model. It orients itself around there's always a block, and you always tell us when that block of statements goes in. Unless you do a thing called driver level auto commit, which I'm not covering. It's in the docs. It's kind of a lesser used case. It's for if Postgres has certain DDL requirements, or you might be using a read-only MySQL follower database. But yeah, when you have begin, it means that you're using atomicity. Does that make sense? I'm going to just go on. I mean, people can join the Zoom and talk also, right? So, I mean, if people want to get on and have a back and forth, we can do that too. You see someone nodding their head, that usually gives the speaker an indication that they're making sense. All right, so I'm going to move on. Tables is constructed indirectly using a style known as declarative ORM. So what I'm going to do is I'm going to show you guys the ORM right now. I'm going to show you actually the most cool thing about the ORM in SQLAlchemy 2.0, which is this new declarative style. And then we're going to do a whole bunch of sections using core, SQLAlchemy core, not using the ORM, but using the ORM class definitions. So people that know what I'm talking about will know this a little bit different when I do. So declarative ORM in SQLAlchemy 2 is super nice, especially that it integrates very well with typing tools. like MyPy and PyLance, PEP44 typing tools work very well with SQLAlchemy ORM declarative classes as done in this new 2.0 style. And even if you get SQL statements and result sets from your ORM models, those will usually have types too. Like you'll know that the first column is an int, Python int. You'll know the second column is a Python float. That works too, which is pretty amazing. And we have integration with Python data classes. And we can still do everything with core. So if you have an app that you don't like ORMs, I don't want to use the ORM. I don't like the ORM session. I don't want to use that. But I want to use engines and connections and select object. You can still make your models with the ORM. You will still have that table metadata just in a nicer form. So I'm going to make that same table using SQLAlchemy 2.0's declarative style. And also, this is at the forefront of the talk because this is kind of a what's new in 2.0 thing. This is the most dramatically new 2.0 feature, which is this new style where when you want to make an ORM map class, what we're doing is we're making Python classes. And each class represents usually a database table. So instead of having a table object, we're going to have a Python class that represents something in our program. And in all these tutorials, I use a class called user, which is like a user account in your web application, like your login, you have users. When you want to make ORM mapped classes, you start with this thing called the declarative base. It's a magic meta class thing. And as you make new classes of this base, the SQLAlchemy ORM will say, oh, that's a mapped class. Let me create table metadata for that class. Let me make sure that I know how to persist that kind of class. To make a base class in SQLAlchemy 2.0, we extend a class called declarative base, which is itself is like a meta class enabled class that just does some stuff. It creates that metadata collection that we saw before will be associated with this base. And for demo, we're going to add in another mixin called mapped as data class, which means that when we do map these classes, they will be also Python data classes, like real ones, not interpolated, like actually uses Python data class on the class. So that's the base, and that's our building block for making new declarative classes that will represent tables in the database. So that just says what I just said, those bullets. So here's the user class. That looks just like the user account table. So in here, we have different kinds of imports. We make a class that can be called whatever you want. That's not the table name. Extends from base. You give it an attribute, class level attribute that refers to what you want the table to be named. Then you have attributes that use Python PEP44 type annotations. That's this colon. So we have an attribute on user called user.id, which is a integer, but it is a mapped integer. And the SQLAlchemy ORM says, oh, that's a mapped integer. Let me make a column with an integer data type. And then also this int has extra stuff like, oh, by the way, when you make this column, SQLAlchemy, make it part of the primary key constraint. And also SQLAlchemy, when you make the data class, don't make this field part of the constructor. So you need to know what that means. If you know Python data classes have a object called dataclasses.field, and the field has flags like an int equals false and KW only. Those are all accepted by this new construct called mapped column, which is new in SQLAlchemy 2.0. It's not in SQLAlchemy 1.4. The next column is called name, and we say this is a mapped string. So SQLAlchemy say, okay, I will use a varchar for that, and it's not optional, so it'll be a not null column. User has a full name column that will be optional, so we will make that a nullable string. And then it has a column called created at that will be mapped to a date time, like a timestamp column. And it will use a data class default factory. So when we make new user objects, which we're not going to really do in this chapter too much, use the data classes default factory of Python's UTC now function to give the object a new timestamp as to when it was instantiated. So this is intended to look like Python data classes. So if you know Python data classes, this would make a lot of sense. People are at first like, well, what's this map thing? That's ugly. What if I just call it int? The mapped, if first and foremost, says to SQLAlchemy, hey, this is not just an int, this is actually mapped, so I want you to map it. That means you can have other attributes that are not mapped, that are also part of your data class, which is nice. And also, this map thing does a whole lot with typing, because as you'll see in the next couple of sections, we use these classes to create SQL expressions with a lot of special methods that are on the class-bound, what we call descriptors. So like the user class.name has a lot of special behaviors. The mapped type gives you all of that. You have to do that because SQLAlchemy does not use typing plugins. There's no MyPy plugin in use in SQLAlchemy 2.0. Everything has to be upfront for the typing tools to see at static type analysis time. So mapped indicates that SQLAlchemy it's an mapped attribute. Mapped column is optional and indicates additional details about how the column should be created. Receives a lot of arguments, including those of data class fields. When you work in the data class, the use of data classes is also optional. That's not a required function yet, but it's going to be pretty prominent going forward. So the user class is called the declarative map class. Someone just said, someone said a question. Okay, does the datetime? Okay, so that's a great question. The question is, does that datetime initializer run at the database level or Python? So the one I just showed you runs at Python. And in the next chapter, we will do the database version because the database version is actually better. As you're correct, the datetime initializer should be at the database level. However, just to show the data class-ness of this, I showed the Python version. So in the next chapter, we'll do the database version. So good question. The user class is called a declarative map class. It has data class methods like init and reaper that correspond to have data classes, sets those up. So here's that. If you've read our tutorial, you'll know that we standardize on SpongeBob SquarePants as our data set, the names of SpongeBob characters and their fake email addresses. So users of older SQLAlchemy versions would notice that I didn't use keyword arguments here. I used positional because data classes give us positional arguments. And you can print it, and the reaper method is there. The datetime came out from the created at, and the data is there, and the ID primary key, which is not part of the constructor, is pointing to none so far. So
can I interrupt real quick?
Yeah.
What made it print? Because it printed automatically when I did the user class, and I don't see any print element within the class.
Let's see if I can remember how to go back. We're in a Python console. Get it?
Yep, got it. Thanks.
We're in a REPL, whatever that stands for. Yeah, sorry, I should have mentioned we're in a magical REPL that there's actually a standard part of Python called console interpreter or something like that, and this uses that. It was someone else's idea a long time ago, and it's pretty cool. So yes, when you see data like hi or whatever that is, it's going to print it. That's
got it.
That is.
Thanks.
So when we did that, we got this table object that's now assigned to the class called dunder table. And from there, you can see this table object, which looks like the one we created before. There's the one we created before. So we originally made user account table. I missed a nullable in one of these, but they're, you can get them to be exactly the same. They're pretty much the same. So there's two ways to create this Python object, which is what's more Pythonic than two ways to do the same thing, right? Well, anyway. So now that we have this table object, and it is in this collection called metadata, which is actually part of in this case, part of the declarative base. We want to actually use the SQLite memory database that we can create and do some create table statements. That'll be fun. So actually take our Python-only notion of a table and run it and make those tables in the database so we can put data in them. So we do the create engine as we did in the first chapter. We do engine.begin. DDL is transactional. SQLite's DDL is transactional, but the PySQLite driver DDL auto commits, but that's an implementation detail. You generally should consider DDL to be something that needs to be committed. So with engine.begin, and then the base class that we used has a attribute called .metadata, which is a dictionary. It points to a dictionary of all the tables that we've made so far. .create all. Okay, I'll create them all. Where do you want to create them? On this connection. Okay. So create all by default checks for tables. It asks SQLite, hey, do you have a table called user account in your main schema? No. Do you have a temp table? No. Okay. Let's create a user account with all the stuff, and there's no server default here yet, and then commit. So now we have that table. So just to show off what's called a foreign key, let's make a second ORM declarative model with its own table. We'll associate it to the user using foreign key. This is a class called address that will hold an email address. So a user in our system can have any number of email addresses that we can contact them with. So address is another class with another table. It has a primary key ID. You can make primary keys of any kind you want, but when we do these demos, we typically have integer, single column primary keys. You can have a composite, it's fine. We have a column called email address that stores the data. And we have another integer column called user ID. That's a non-nullable int that will refer by what's called a foreign key constraint to the user account table .id. So that means that for every address row, it will have a number in the row linked to this user ID that must refer to a primary key in the user account table. So that's what we call a foreign key. Now, whether or not there's a real foreign key constraint in the database is another matter. SQLite has optional foreign key constraints. In this case, SQLite just wants to know that there's a foreign key. And we will actually create the constraint, but SQLite won't enforce it, but that doesn't really matter for what we're doing. So we can emit more DDL for that directive. With engine.begin, create all of that on that connection, and that will, again, checks for user account. Well, that table is there now. Okay. Well, how about address? Do you have that table? No. Temp? No. Let's create that table. With a foreign key on the user ID column that references the ID column in the user account table. So now we have two tables in the database with this foreign key. So this model is what I'm going to use for examples in the next few chapters. So user and address, user is a one-to-many, to address is a foreign key. And that's pretty much, yeah, all for the metadata. So that was basically making table metadata using SQLAlchemy 2.0's core, SQLAlchemy 2.0's ORM declarative. The next two sections will illustrate the use of these models to create SQL statements. And as I mentioned, we're going to use just core only for a while. There's going to be just very little ORM, and if I speak too slowly, very little ORM. So we'll run insert, select, and in theory, if we had more slides, we could run update and deletes. I'm skipping those two. We're really short on time. Using the connection, and we're going to get plain rows as we've seen the row object back for results, just so we can see how to run, queries. And then later, as I lose my voice completely, we will pull in the ORM session and do some real ORM back and forth.
Hey, another stupid question.
No question is stupid.
What are you doing to get the SQL readout of what you just did?
When you make an engine, you can say echo equals true, and I didn't do that here. Here I am live typing con 1 2 3 4 con exec driver SQL 1. So when I did that, we got a lot of logging, and that's because this echo equals true makes a Python logger with basic config, and these timestamped logging lines is what that just did. These are regular Python standard lib logging. So this slide runner actually sets up a Python logging like it does this logging basic config. If you're familiar with Python logging, it did this, and then it said logging get logger SQLAlchemy engine set. It did this set level, whatever level logging info. That's what you do. If you do this, if you take any SQLAlchemy program, you do that, you will see this in your standard out. Or if you do this on your engine, you'll see logging. There's a chapter on logging, how to set it up. So there's two ways, again, the theme here, two ways of logging. The easy way for just debugging something quickly is the echo equals true. But this slide runner has set up Python logging with a custom formatter that has this SQL thing. So does that make sense approximately?
Yes, thank you so much.
Where to look. Great. Not stupid at all. Okay. All right. So that was that was really the biggest what's new in SQLAlchemy 2.0 chapter, is that new declarative style, which we have a lot of docs for, and there's also a migration document if you have existing 1.4 models. Here's how to transition to the new version. I will note that MyPy type checker 1.1.1 was released, and there is a bug in how they did a new feature for data classes. So if you're using data classes, new SQLAlchemy data classes feature with MyPy, check the docs. There's a workaround for this unfortunate mistake MyPy made, and they hopefully will fix it soon, because if they don't, I will be getting lots of bug reports blaming me for it. All right, so now we have metadata that describes tables. We have a database. We have a way to create tables in the database, and the tables are empty. So next we're going to put data into them. So this section will show the insert construct, which corresponds directly to a SQL insert statement. And we'll use that same ORM-centric metadata model with a little change that someone had asked about. So here is that same ORM-centric metadata model. We're just using the user class. We're not going to use the address class here. Everything that you see here is the same code as before, with the one exception, as referred to. On the created at column, we will add a data class directive saying, don't include this as part of the constructor. And instead of having a default factory that's a data class Python thing, we're going to have server default. Points to a little doohickey here called func.now. Func in SQLAlchemy is a namespace that creates SQL functions. And SQL functions, the most common are like string functions, like lowercase and contains, and date functions like current timestamp, math functions like max and min and whatever like that. Well, aggregate functions, sorry, not really math functions, but you know what I mean. Anyway, func.now creates a current timestamp function, and that's just something that's in the docs. You know how to do it. Func.now. So when it creates the table for this user account this time around, it'll have a server default, meaning that anytime a row is inserted into that SQLite database table, no matter how it got there, the SQLite database itself will add a timestamp to that column. So it's a server-side timestamp. Now, technically, because this is a SQLite database, it's embedded. It's not really a server, but we're just calling it a server because it pretends it acts like a server. So it's technically not server, but you know what I mean. So that's the server default. So again, create engine with engine.begin as connection transaction, create tables, and we get double, because I set up a Python logger like a dum-dum, that is going to log twice. So here's our first adversity in our talk, is I'm going to cut out and run the thing again so that logger is gone. Thinking on my feet. Was that chapter 4? Let's try that again. Great. Disaster averted. Create. That was a total surprise. I just fixed a bug in live coding. All right. User account table again. And this time, the created at column has a default of current timestamp, and it's not null, meaning any row that goes in here, created at will never be null. It'll always have a timestamp, which is awesome. And when you make timestamps, yes, you do usually want timestamps to be server generated. It's just easier. It's just better. There's no chance of not having a timestamp. And also the timestamp matches when the data went in the database, as opposed to when your Python program had it in memory. Could be different. So that's just saying what I said. And the insert construct starts with a single argument, which is the table, or a table representing ORM class, which I will often refer to as an ORM entity, that is the target of the insert, the thing that will receive the new row or rows. So in this case, it's the user class. It's part of so the table, as we saw before, is part of the user class. So the table object that we don't have to worry about is what actually is used by the insert construct to make the statement. But we don't have to worry about that. We just do insert user. So we make an insert statement into user. If I were to print this right now, it'll stringify. And you'll get this very generic insert with all the columns, meaning it's going to insert all 4 columns with some unknown value that has not been specified yet. These are called bound parameters. It's a parameterized SQL statement. So with this insert, we want to give it some actual data, which will be the familiar SpongeBob SquarePants as before. Insert statements in SQL have a values construct. So insert, we want to actually put some data in as values. So we will add that using the insert.values method. It accepts keys that match database column names. And actually, you can name the columns in a separate way for your Python versus SQL, but for example's sake, just column names. So insert statement is the same object, and then we're going to generatively build onto it using a pattern called method chaining. I call it generative, but it's really formally it's known as method chaining. It's in the Gang of Four book. Insert statement equals the insert statement dot values, and then add the SpongeBob name and the SpongeBob SquarePants full name, and that gives us a new insert statement that has more stuff in it than before. So we stringify that, and again, well, it seems to know about name and full name and not the other columns, but it still is not giving us SpongeBob is showing these bound parameters. These are parameters. Where's the data? Where does SpongeBob go? So it's there. All SQLAlchemy constructs are very aggressive about taking any literal strings, ints, bools, datetimes, UUIDs, JSONs, and shuttling them away into parameters. It's called the bind parameter object in SQLAlchemy. It's mostly invisible, and that's why when you see statements, you'll see these parameters printed everywhere. You can see the data if you want using this utility method that is not for normal use called compile. So we did a compile here, and on the statements, a special method. We sent some very esoteric arguments to it, and with those esoteric arguments that are in the FAQ, you can see SpongeBob SquarePants is the data that's actually going to go in the database. But when we run the statement, it'll be parameterized. It'll be sent as a separate argument to the database driver. So let's run the statement. Let's begin a transaction with engine.begin, execute the statement. With engine.begin, a transaction as a connection run this statement. And we will see the statement runs with parameters that seem to be question marks now, which they weren't. I see there's a question there. I'm going to get to that in a second. Question marks, and then the values of the parameters there. I'm going to just do this one thing that'll answer the Pydantic question. This question mark thing is because the SQLite driver uses question marks as the default bound parameter format. So an interesting thing is when we print insert statement, it shows these colons. But when you run it on SQLite, this question mark. That's because when the insert statement is run by the connection, the stringification of it is done in a dialect-specific manner. So if we were to run this statement on another kind of database like a Postgres, you might get a different bound parameter format. There are actually 6 bound parameter formats, and there's actually in SQLAlchemy 7 because async PG uses a different format. So someone has a question about Pydantic, so he wants recommendations for Pydantic. I think SQL model is great because my main hardship in life is user support. So if people use SQL model and they have problems, they can go to SQL model and get support from them too, and that's always good. So I like people to use other things. When I forgot that man's name that wrote SQL model, but when he wrote it, I hadn't done the SQLAlchemy 2.0 thing yet. So I think it's going to be interesting to see how SQL model, which has also a data class-like declarative approach, versus SQLAlchemy's approach shape up. And then also data classes. Pydantic has this thing where there's this separate user input thing. I don't work with Pydantic. I do know that they have support for this 2 classes thing. I don't know how much of a solution this is for people. Pydantic also has data class, its own data class feature. And we have added, it might be released by now, we have added a little callable to SQLAlchemy's declarative where you can plug in Pydantic data class thing. And it would seem to me, not knowing Pydantic very well, that if you use Pydantic's data class feature with SQLAlchemy's mapped as data class decorator, mixing class, there's also decorator, mixing class, and you set it up so that SQLAlchemy's mapped as data class uses Pydantic's data class callable, I think you can have the best of all worlds. But I don't know to the extent that Pydantic's own thing versus a Pydantic data class is different. I have noticed that Pydantic's data class just seems to do the validation thing. That is what people use Pydantic for. So I would say look at Pydantic's data class integrated with SQLAlchemy's data class thing. Should be the best, but there's options. Yeah. Okay. All right. So we back to the insert. We inserted with the question marks. So what we just did there, we ran an insert statement that had a specific dot values clause. So when we normally use inserts, we normally don't have to use the dot values. We can rely upon SQLAlchemy itself to generate the values for us. I'm about to cough because I have a cold. Was that an hour? 15 minutes went by on the cough once, so I'm pretty good compared to how I was coughing before this talk. SQLAlchemy generates the values clause, if not otherwise given, based on a collection of parameters passed to the execute method step. So I just tried the speech thing probably got screwed up. Passed to the execute method separately. So we showed connection.execute is given a statement. There's a second argument there, which is the collection of parameters, which can be a dictionary or a list of dictionaries. And I'll show you that. Execute method. And when you pass a list of dictionaries, SQLAlchemy will insert the list of dictionaries in bulk using one of two different approaches, depending on what you're asking it for. The automatic generation of values works by inspecting the keys within the first dictionary given. So if the second dictionary has the wrong keys, you're going to get an error message. The convention of keys match column names is the same as that of the insert values method. So here's the usual way to just get raw data without using SQL functions to generate data into the database when using core. When using ORM, it's all different. Well, you can do this with ORM as well, but the normal ORM way is something else that we'll show. But if using core and just want to do it, or you just want to use an insert, I don't care about object relational. I have these dictionaries. Put them in the database, please. This is the way to do it. Insert user and send the dictionaries over. And you can do that with ORM too. It just depends on what you want to do. So we begin the transaction, run the statement, and we send it just the insert user again. Now remember when I printed a stringified an insert user before, it printed all the columns, just expanded out. When you send the set of parameters, it will limit the values to just these parameters given. And in most cases, depending on the driver you're using, and depending on some other things about the statement, it will use a database, a Python DB API called execute many. So .execute many, it receives the statement and a list of parameters. Someone was knocking on my door for a second. Okay. So in this case, we see the same statement as before with the question marks. And then we see a list of two sets of parameters. And you see also SQLAlchemy's format is always named parameters with dictionaries. When the driver uses what's called positional parameters, like these positional question marks, it converts the dictionaries into tuples. That's done for you. So Python's DB API raw says, hey, depending on what driver you're using, you either have to send dictionaries or tuples. And SQLAlchemy thought that was a little bit, arbitrary. So with SQLAlchemy, it's always dictionaries, and they get converted as appropriate. So most drivers for this statement will use the execute many, which means that the driver receives the statement, it receives a list of parameters, and it will do something on the back end to run those parameters in as fast as possible. And it could be using a prepared statement. For SQLite, I think it's just written in C, just runs really fast. It just runs the same statement over and over again with different parameters. The point is it's supposed to be faster, which usually it is. And for some drivers, it's not. And for those drivers, SQLAlchemy has changed what we do to create better performance. Okay, so that's the end of inserts. That's the raw insert. So when you have some tables and you want to put data in, the insert is the most efficient. Well, outside of using bulk routines, but within SQLAlchemy and easy code, Okay, so anything on inserts as we go on, I guess people will come up with questions as I do the next chapter. Okay, so we have 10:54 and we're done at 11:45. So I actually have a lot of time. Yeah, I did a run through this and it took longer. Okay. I see nothing happened in the chat, so we'll just take it as it comes. Now we're going to select some data. And I should also note that this chapter, as I just started it, it just ran a bunch of SQL already. So those data models that we've been using, the user and address, were just generated for us, and they're here. and also a bunch of data with funny SpongeBob SquarePants character names is in the data. So we'll be selecting some of that data. So in the previous section on engine, we introduced this simple construct called text. And it'll look like this. So if we have here, as we have these tables, like we have a user account table, if I want to select the name column using a regular raw SQL statement, I say select name from user account. And I wrap that up in the text, and I send it off to a connection. And we don't need a transaction here because we're not going to commit anything. So .connect, give us a connection for row in each row of the statement, print the row, and give us the .name column. So easy enough, right? So that's the textual select star from table. And you can always do that. There's nothing wrong with using the text construct. Just use it. It's very great. It does everything. You don't need to use SQLAlchemy's other thing, except if you want the other things it provides. I'm going to write the same construct using SQLAlchemy's more mainstream core SQL expression language, using a construct called select, right? So there's insert, select, update, and delete. It's pretty easy. We're going to use this ORM-centric method. So no, we're writing core, but we're using the ORM a little bit to create SQL expressions. And this is something that you could do in other older SQLAlchemy versions. But as of SQLAlchemy 1.4 and 2.0, we made sure it really works as well as it can work. So the class-bound attributes on the ORM models, like this user class that we've seen a couple times now, the attributes like .id and .name at the class level, meaning the user class.name, represents columns, such as user.name. So this is the user class, right? User is a class. It's not an instance. If I say user.name, it's this funny thing that's a SQLAlchemy thing, but the object that this is in Python is called a descriptor. Python descriptors are awesome, and SQLAlchemy uses them a lot. If you ever use the Python property decorator, which everyone does, that is the most commonly used descriptor in Python. So user.name is kind of magical. It's not just the user. It's not just like an empty, it actually wouldn't be present at all if you'd made a regular Python class or a data class. It's significant, and it's got data types. So if we make select user.name, we've just made another SQL select. We made a SQL expression object the same way we made that insert construct before. Same kind of thing. So the above statement means select the name column from the user account table. So the intent here is given as your select, meaning that's what we want to do. That's our verb. We want to select the name column from the user table. So by using this Python attribute, user.name, instead of just saying string name, the intent that where this name comes from, the context that it has, the data type it uses, is all inherent in that statement. SQLAlchemy knows that that's a string. It knows if the database needs some special encoding thing to happen to get the string back. A whole lot of information was imparted in this that would not be imparted by a simple string. And the simple string would be longer. So this is kind of me making the pitch for SQLAlchemy cores, that there's a lot of what we call automation. It's not that I don't know how to write a select. You should very much know how to write a select. You should know SQL. Anything you do in SQLAlchemy, you should know what the SQL looks like, and then you write it in SQLAlchemy's version of SQL. So select the name column from the user table all at once, and then you print it like we did before, and we see there's select.name from user account. The from clause, we didn't have to type it because we knew what it was. SQLAlchemy knows what it is. Well, obviously that's the from clause. You can say that's implicit, but it's really not implicit. It's explicit that we said, well, user is the class, so of course that's the from clause. What it is just it's being non-redundant. Anyway, that's my elevator pitch, but I hate elevators. So as we did previously with the text construct, we can run it using connection.execute. As we've seen 100 times now, engine.connect for row in, run the statement, and it's the exact same code as before with text, where we have row.name for each row in this statement's result set. and we see the same data, which, by the way, are characters from my well, actually, my 8-year-old doesn't watch SpongeBob anymore, but he liked it for a while, Anyway, so the arguments that we send to that function up front are a series of columns or tables or corresponding ORM maps classes / entities, other so-called selectables like aliases or subqueries, and SQL expressions. And I'm actually going to illustrate, I'm going to show you all of those things, but really quickly. You can go back later and look at the course source codes. Examples of select include select all the columns from a table. So just like the insert, select user. That'll give you every column of the table. Select from specific columns. Okay, select ID, name, and creator that. It'll give you those columns in whatever order you give them. Select from a series of tables or columns or whatever from more than one table. This is different. So this is select the name column from user, select the full name column from user, and as a more special case, also select the email address column from the address table. Now, what's that going to do? We have two different things to select from. So the default, well, you see what it's doing. The default behavior is that the from clause is going to put both froms in there with a comma. Now, if you were to run this statement in a database that has data like this one, what it's going to do is it's going to get every row from user account. It's going to get every row from the address table. And it's going to cross-link them all together in every combination in what's known as a Cartesian product. Now, Cartesian products, when you use SQL, are something that you usually want to avoid, because if you have two tables, one has 100 rows, one has 1,000, you can get, math geniuses can give me how many rows that would be, because I couldn't possibly guess it, but you can easily crash your computer with gigantic Cartesian products at the point. The math is hand wavy. I think it's called multiplication. Here it's popular. As we see in that last statement, the from clause expands to include all the tables we are selecting from. So when we're selecting from multiple tables like that, we normally want to join them together so that we don't get this Cartesian product. We get, for each row, we have the rows are linked, because we know that the address rows have a column called user ID that refers to the primary key of user. So we should have the rows be linked up so that the user ID of each address row matches up with the user that we're seeing, and that's called a join. And there's a few ways to join SQL. There's an implicit join where you could say select from user comma addresses where user ID equals address user ID. That's called an implicit join. Or you can more just differently use what's called an explicit join, which means there's a word in the SQL called join. And that's usually what we do. You could do either way in SQLAlchemy, but join's more explicit. It's more obvious what you're doing. So in SQLAlchemy 2.0 and also 1.4 in the new API, the easiest way to do this with the kind of situation we have here is called join from. And the reason it's called join from is because there already is a join method that the join method does kind of an implicit thing that is very useful if you have ORM relationships. But if you don't have ORM, which is the thing I haven't shown you yet, if you don't have this ORM relationship thing that is not in our models yet, join from is more explicit and allows you to say, what would you like to join from to? It gives you the from and the to. Because here we have a select user table and the address table. We want to join from the user table to the address table. And we can just do that. And what's interesting here, there's actually a third argument that join from takes, which is called the on clause. And the on clause is not shown here. The on clause illustrates how you would like to join the user and address tables together. We don't have an on clause written in our code. Yet, when we look at the statement being printed out, there is an on clause. And that got generated for us. The reason that happened is because when we did our data model, I think I actually have a close-up of it happening. Here's the close-up. Close-up? Yes, great. This was the data model that we built, is that we made the user table ORM model and the address ORM model using this little thing called foreign key. So when we made the address model, we said, hey, address has a column called user ID that is the natural foreign key to the user account.id column. And whether or not we made this table in the database, whether or not there's actually a foreign key constraint, the table metadata that we created was able to give us information that, let me see if I could do this. Do you see it? Statement. Yeah, that metadata, the fact that we put the foreign key in the metadata gave SQLAlchemy what it needs to know that, hey, a join from user address normally by default, if not otherwise specified, should join on the user account ID to use address that user ID. And that is an example of SQL automation. I know what a foreign key constraint is. I know what a join is, but I don't want to type it. And that's, again, I'm going to probably say this a lot, apparently. SQLAlchemy wants to automate things. And that's what they like. If you want to say SQLAlchemy is a SQL abstraction layer, that's fine. But it's not going to hide that you're doing a join between two tables. You need to know it's a join. We're not going to pretend it's some kind of magical concept. You want to do a join, but I know it's very redundant to type the on when you can just put it up front. So this is automation. So that's how that happened. User address knows how to do join from. So putting it together, I think this is going to run. This is going to run the statement. Okay, so this is going to run. This is the same statement with a join from, and I'm doing this just so you can see the data that I put in the database because we're going to do some other queries. So just to see all the usernames and the full names and their email address is SpongeBob SquarePants has one email address. Sandy Cheeks is the squirrel. She lives in a big dome, and she has, because she's a techie, she has 2 email addresses. And then Patrick was SpongeBob's friend. He's a little more low tech, so he's still on AOL, but we still love him. So that's just the data that we're going to be selecting from. And finally, there's a whole world of more complex select statements using aliases, subquery. This is like a preview of a query that's going to be too difficult for me to explain. Well, I can explain. It's not hard, but here's a query called select usernames that have more than one email address. And to do that kind of a query, you need to, what we say, compose the query based on individual selects that will be joined together to select from each other. And this is another big SQLAlchemy thing. This is actually one of the main reasons I wanted to write SQLAlchemy in the first place, was that I was working at a shop where we wrote ginormous queries for an Oracle database. And I found that when you type these queries, you have to type the same query and then type it all over again over here as a union, and then type the same thing with it was like, this should be programmatically generated. This is really, really very error prone and verbose to generate these queries by hand. It'd be nice if I could compose them using objects. And that's what this is. So I have a subquery here that will give you all of the address user ID, all the user IDs that have a row in the address table, and the count for how many email addresses are for that particular ID. And then we're going to group those counts by address ID. So for each user ID grouping, we'll get the count of a user email addresses. And then we're only going to include those counts that have more than one email address, and which we know from our data is actually Sandy the squirrel is the only one that has more than one email address. Okay, so that's going to be called a dot subquery. And we're going to then select usernames from the user table and the count of email addresses that they have from that other subquery, join from the user table to the subquery. And then again, no on clause. So that foreign key thing that we have is smart enough to know, even from a subquery, it's going to dig in there and be like, well, this subquery actually has the address user ID column. I can join to that. And if this subquery had more than one column that the user could join to, it would raise an error. It's not going to do something that it can't. It's not going to guess. It's only going to join for you with the on clause automatically if it's completely unambiguous what query you want. If we were to add other columns to address that also refer to user ID, it would raise an error saying this is ambiguous. You need to give us the on clause. So we're going to join from the user table to the subquery and get this fun data, which is Sandy the squirrel's username. And Sandy has 2 email addresses. And the other users that have 1 email address were not included because we filtered them out using having. So this is just kind of like where this is going. Not really in this talk, but that's like when you learn SQLAlchemy, special language, this is where you go with it. You can make composable structures. So back to, that was kind of a jumping ahead preview. I don't know why I put it there, but anyway, let's talk about the where clause. How do we do the where clause? If we did this select, we didn't do a where clause. There was a where clause over there. There was a having clause actually over there, which is kind of like a where clause, different context. So when we have this user.name attribute, yes, I will show you that now because I'll show you what. So when we do user.name, we're going to do all right. So let me just skip. So the question is there an as statement, username as the name? Yes. So we had, if we do print select user.name, we see just select user account name. Now, users of older SQLAlchemies will recall that this would often be a SQL user account name as it would have this big generated label name. That's still around, but it's not really needed anymore. But if you do want to select things with labels, it's called label. I just gave it away. Label the name. And then you could say address email, address label the email. These are not good label names because they're not even the same convention. But that will give you those label names. And if you get a result back, like you say you had a row, you would have row the name would be the attribute you get back on the row. So yes, labels are very important, and especially if you have the same column in different contexts. And also if you have SQL functions, SQL expressions that don't have a clear label, you'll be using .label a lot, and that does the as for you. Okay, so back to the where clause. Let's try that. Great. Excuse me. It's catching up to me. Class attributes like user.name are the foundation of SQL expressions. So if we take user.name and use the Python equals operator with a string, this crazy thing happens, and people that know SQLAlchemy are very used to this. And if you've not seen this before, then it's probably weird looking. Python lets you override methods like eq and any and dunder add, dunder minus sub, dunder lt. There's math operators. There's comparison operators, Boolean operators, bitwise operators. You can make Python objects that repurpose all those things. And so SQLAlchemy, like a few other tools maybe these days, repurposes the Python operators to an extent to allow you to write Python expressions that become SQL expressions. And this is a popular feature. There's other ways to do this, but this is the way that we've done this thing for a long time. So when you run user.name, which is this special Python descriptor, and you run the equals operator, we have a special EQ method that did some stuff. And instead of it spitting out a Boolean, instead of spitting out true or false, spit out this object called a binary expression. And the binary expression means it has two, right? It has a left side and a right side and an operator. And that's a component of the larger SQL construction language. You don't need to know about binary expressions. Just I'm printing it out, excuse me, so you can see what it is. And then also you can see that we had this literal Python string that SQLAlchemy, as I said before, very aggressively shuttles it away to become a parameter. So it's hidden away. You can't see it. And again, like with the insert statement, you can use, right, the parameters come out when you don't do connection.execute. But they can also be seen, as before, using a utility called compile. So if you want to see SpongeBob, you take your username equals SpongeBob binary expression, you put it in some parentheses so you can pack it away, compile that thing with some esoteric arguments that are not very good looking. Maybe someday we'll make them nicer. And then you can see that the SQL expression we have here is user account name equals SpongeBob. But when we run this statement, you're going to have a parameter. So the idea of parameterizing things, probably most people on this call have heard of SQL injection attacks, which is the most common vulnerability in database applications, is that people type into the web forms, what's your name, semicolon, drop table, that whatever that is, right? It's all these ways of injecting. And if you run a lot of older applications, a lot of the old PHP stuff, PHP was just rife with these things. People did not escape their strings, and then these semicolons quoting tricks would come in and wreak havoc with their databases, because you need to make sure strings, especially, or other Python, other data values that are ints, which might be secretly sent as strings anyway, because we're in a dynamically typed language, they don't make it through, they get escaped. So the best way to do that is to use bound parameters. parameterizing statements also lets the database use prepared statements and there's optimizations. And also SQLAlchemy's SQL caching system relies upon these parameters as well, because the same statement with different parameters will be cached as the same thing. Even though this SpongeBob is embedded in there, there's a caching system that caches this user name expression in an agnostic way. Way too much detail. Anyway, here's some other operators quick. You'll see less than, greater than, pretty easy. Fancy string like contains, like I contains, I contains expands out to this crazy lower thing with percent signs. And then in expressions are very, very well supported now. They look a little weird the way we compile them. So here's the literal bound. So you can say user account name in, you do parentheses, you pass a list of the things you want to be in. And if we print that with the literal binds, it works very nicely. If we, and you will see it later, it prints out in kind of a funny way without the parameters. We can add these expressions to their select object using the where method. So we have select username, where username is there. When we print it, there's a funny thing here. This is not a bound parameter. This is a SQLAlchemy expanding parameter. When SQLAlchemy runs this statement, it will look at the data being passed, see that it's 3 strings, and then expand this out into 3 parameters. So when you see this weird post-compile thing, don't panic. Where can be called multiple times. The default way that those are, the only way that join in this context is by and. There's also an or, but it's a different construct. You could say where username is SpongeBob and where user ID is greater than the value of 1. And we can put things in a method called order by, expressions again. So statement that order by. Again, we're using this method chaining pattern where we have this object called select.where, select.order by, select.this, select.that. Keep building, keep assigning the return value to a new object each time. Add a column expression. Let's select some more goofy columns. Here's select what's called a literal construct with some text and string concatenate that to the user full name column. String concatenation is with the plus sign against a string. If we use the plus sign against integers, it would do math addition. It's so the operators in SQLAlchemy can be dynamic in that way. Running the statement. This is just basically a kitchen sink thing again. Just like a show-offy. This is where you can go. This big statement with the user account name, a string concatenation. String here got turned to a bound parameter. Here's the in that created parameters on the fly for that, and some other stuff, and then we get some data back. So that's kind of a whirlwind tour through select and .where clauses and stuff like that. I'm going to keep going, and if people seem to be jumping in with questions as they happen, so just feel free. The SQL expression language intends to allow any SQL structure, any statement, to be modeled as a Python expression. So SQLAlchemy goes very far with this. Things not covered here include updates and deletes, which look a lot like these inserts and selects, unions, other kinds of set operations, CTEs, common table expressions are called, window functions. There's OLAP operators, there's set returning functions, JSON functions. Basically everything that any database can do, we either support it or there's users coming to us with, please support this. Again, all these things can be done as a textual string. You can always just say text and do your SQL. You can always do that, but everyone usually recognizes the utility of the Pythonification of these constructs. And so everything is pretty much getting Pythonified over the years. So we have a lot of stuff.
When you say everything can go into text, is that built into SQLAlchemy as well? The text option?
In the beginning, I showed you this SQLAlchemy construct called text.
Right. Okay.
Right. So that means you can take text, you put a big triple quotes, make it really big, and put gigantic wall of crazy SQL text, whatever you want. And it's not SQLAlchemy has nothing to do with it. It'll just send it along. And people do that. And we are working, we have APIs that I just got a bug report about one, where you can relate the rows coming back from these textual statements to SQLAlchemy things that are useful. Because always SQLAlchemy never wanted to impose the select insert model on people, but it just supplies a lot of advantages, but if you have the textual SQL and it does what you need, then you're done. Run your text. There's no problem with that. So when people are writing SQLAlchemy SQL expressions, the hope is that you can just think in terms of SQLAlchemy first and foremost, because it's trying to look like SQL. It's trying to look like it's not that different. I mean, it was select user.name and not select name from user. But see, it's hard for me to really argue with this because I've been doing it for like 18 years. It's pretty intuitive to me, which, you know, of course it is. So, but the hope is that people don't have to think in terms of, here's the statement, how do I write this in SQLAlchemy? Like, that's kind of, eventually you get past that, I would hope. And people will blog, no, I know, and I hate, it's terrible, whatever. Anyway, that's the hope. And the Python objects for SQL expressions allows for composability is the main thing. And also database agnosticism, the same statement can run on Oracle or Postgres or a SQL server without any changes, is also a goal. But that's not a complete goal because you can use all kinds of database specific functions and things in your statements. SQLAlchemy is not going to reduce the language down to the lowest common denominator of all the databases. You can do all kinds of Postgres JSON functions, and that statement won't run on SQL Server. So it depends on what you're running, and you need to know what you're doing. SQLAlchemy is just automating the work. It's not designing the work for you. So that's the select chapter.
Quick other question about joins. Can you join lefts, inners, outers?
So joins are inherently left, left outer join, yeah. So a join is left, so yeah, as for an outer join, there's an outer join from. And a right join, we don't talk about right joins here. No, a right join is really, we don't have a right join because right join is really, there's no way I'm going to show it with my typing, it's too complicated, but a right join is just a left join, a normal join in reverse, a right outer join. I think maybe once in the past 18 years, we had someone ask for a right outer join, and we're like, just flip your clauses around. And no one's really had a problem with that. So yeah, you have there's some other joins like cross join that I'm not sure if maybe that's the SQL Server specific thing. But yeah, generally join and left outer join are the two joins. Oh, there's also full join. There's this thing called full, which I don't really know why people use that, but a few people use that. There's a few options. It's in the docs. I mean, we base it on, in 18 years, how many people have asked for this feature or that feature? Like if, you know, we have millions of downloads and whatever's very important, people ask for it. So that's how we gauge what's important to have. So does that answer the question? Yeah. Right. So that's that.
Thanks.
Yep. So this is the last section that I think I'm gonna get. So 11:23. So we have 15, 18 minutes left or whatever. I can't do math when I'm on a talk. 22 minutes. Sorry. Can't think on the fly. So I'm gonna do some ORM. And I'm going to just use the important things to know when using the ORM. So we've done all this select, insert, statement. We've done basically statements-oriented programming, right? We want to talk to the database. Let's write statements and send them to the database. That's the way we want to talk to a database. Now, the ORM gives us another way of talking to the database, which is in terms of Python objects and their state and mutations on their state. And the ORM will generate the insert update deletes for you based on those changes in state. The ORM also lets you select objects, and for that it still works in a statement-oriented fashion, but it gives you back Python objects instead of rows. Well, it gives you rows, but it has the feature that it can return some of the columns in those rows as fully formed Python objects that themselves can be mutated to give you more SQL modification stuff. So this is the new dimension, and this is my intro. When I first did this slide, I got into the fonts. So this is ORM time, and that's the end of the funny fonts, the ASCII fonts. Okay, so we again have the ORM model again that we did before. So again, we're doing just the user class, and as is the case before, we have the server default. It's the same thing that we use for the insert chapter. And as we've done about 4 or 5 times now, we will generate the schema on this SQLite connection. Oh, excuse me. This talk, I'm going to bed. I'm sick. There's the table. So we've already been working with ORM-centric metadata models, but we weren't really using the ORM. we're using the ORM classes to make select statements and inserts, and we can also do updates and deletes. To really use ORM-centric patterns, we will add the use of instances of our ORM mapped classes. So that is, well, this is the class, that's the user class, right? Which we've done a lot with it. This is an instance of a class. So when we construct an instance of user using its under init method, and we get an object. So we have the class and the object, or the instance of the class. Excuse me. Both of these areas of use are significant in SQLAlchemy. Usually with an object model, usually with objects, you make the class and then you're done. You deal with the instances of the class. You have objects, which is fine. But with SQLAlchemy, the class itself is also very important. So what we want to do when we have instances of user, so stateful instances with data in them, what we want to do with the ORM is we want to persist their state to the database, and we want to load their state from the database back into objects. So before we were getting rows back with individual columns. When you use an ORM, you kind of want to see those objects with the state in them going back and forth. That's why it's called object relational mapper. And in my opinion, if you're using an object relational mapper, it implies you are doing object-oriented programming. Like if you had a functional language, I don't think you could have, I shouldn't get into this, but I think ORMs imply that there's a class construct of some kind. A stateful, usually mutable, mutable state, which is in some worlds evil. But for classes, Python classes, it's mutable state is what we're doing. If you don't like mutable state, don't use an ORM. That's what I would say. Use core. Those tuples are not mutable. So anyway, back to the ORM as I am digressing. To achieve this, we'll use a new kind of tool that can mediate between those instances and SQL data modification language statements and SQL result rows. And it'll do it all within a transaction the same way that the engine connection paradigm has given us transactions all the time. The object is called the session. And the session is to the ORM what the connection is to the core. It's the thing that interacts with the transaction, of which there always is a transaction, because the Python database API, as soon as you connect, there's a transaction. As soon as you start setting commands, everything is lazily initialized. But from SQLAlchemy's point of view, there's a quote unquote transaction, even if it hasn't fully set itself up yet. So in the similar way as the connection comes from the engine, the session comes from a factory called session maker. There's actually some other ways to make sessions, but the pattern that people seem to be into, and it works very well, is to have this factory called, like, you can make a session directly if you want, but for the purpose of the tutorial, I will show how the session maker is kind of a factory for sessions, and it has some patterns that line up exactly with engine and connection. And that's all kind of a SQLAlchemy 2.0 things that we want, the patterns of resources being opened and closed and the patterns of transactions starting and closing to be consistent between core and ORM. So this conceptually shouldn't be too much different. The session maker as a factory, when we make that, is given an engine. And so the session maker, when it makes new sessions, will send the engine to the new session. And then the session, when it is asked to start talking to the database, will procure the connection from the engine, which sounds crazy, but when it works, it's not that hard. It's not that complicated. It just sounds hard to explain it one link at a time. So the engine is passed along to the session. So the session maker, we will assign it to a variable that is kind of thing we make globally. By the way, I probably didn't cover this. When you write your SQLAlchemy program, the engine is usually a global variable, like some kind of module level thing. You don't want to make an engine every time you want to connect to the database. The engine should be, it's a connection pool. It's a long-lived object of some kind. So you want to have it either globally or in some kind of registry that's global, something that every part of your program can go and refer to that same engine throughout the lifespan of the program. The session factory, if you're using that, is similar. It should also be a long-lived, persistent application scoped object. Let's not say global, let's say application scoped. I will see a lot of users sending me code where they're making an engine and a session factory every time inside of a method. New engine, new session factory, then new session. And it's like, that got you nothing. That did nothing for you at all. You did not need a session factory. You already had a session, and you just did a whole lot of Python work for nothing each time. Then that should be global. Anyway, so session factory and engine are global or application scoped. Session factory is a new session maker here that's bound to an engine. Nothing happened yet. Nothing was factoried yet. Okay, so the session maker creates a session when we call it, like a callable. So the session factory is here, and we just basically say session equals session factory, call it. That's the factory. And then we got back the session object, and that's the thing that can talk to the database. It still didn't connect to the database yet. Everything is very lazy initializing. Now, if session maker is a factory for a session, like an engine is a factory for the connection, why isn't the method called session factory.connect the way it's called engine.connect? Well, because the session didn't work exactly the same way as engine.connected. The session connects to database engines on demand. So nothing actually connected yet in this case. So that's why session factory to session's got a little more longer of a sequence chain to actually be connecting to the database. As an example, we can make a connect right now just to show what it looks like by using a method called session.connection. Session.connection is a method that you don't normally need. I'm going to show it because it is one immediate way to tell the session, okay, start your transaction, start your connection, get going, and then show us that connection that you have. It's not called connect because it's going to actually return us that connection that remains persistent within the session. So it's kind of like get the connection and create that connection if it doesn't exist yet. Again, I'll run the code. It does the begin implicit that we've seen before when we do a session engine.connect. We get back the connection that we've always seen. But this is just demonstration. We normally don't really have to use .connection. I just wanted to show people that the process of session is you have session factory, then your session. Then when the session is asked to begin doing work, it will then lazily initialize and connect and create a real database transaction. So once the session has established a connection, it's considered to be in a transaction. And that is technically incorrect. I should have fixed the slide. The session is actually considered to be in a transaction the moment you start doing things with it. Once it gets the connection, that's actually a second level of being a transaction. The session actually has its own notion of a transaction before it even connects. But usually, roughly, hand wavy, the way I frequently operate, when it has a connection, it's considered to be in a transaction. That same connection object will be used until the transaction ends. When we're in the transaction, there's some other things we can do with the session, but first of all, you can run statements with the session, and when you use the ORM, you're still going to use select statements like we did before, but when the session runs select statements, they do kind of a more special thing than before. They can return objects, but to run that statements, we will still use session.execute the way we did connection.execute. There's methods called session.scalars that gives you a list of individual columns or objects. Excuse me. And session.scalar, which will give you just one column of one row and be done with it. So there's no limitation with session execute. Session execute will go right through to connection execute. So again, we can go back to the beginning with text again. We can do select hello world all over again with the session, and it will essentially pass through this statement down to the connection and give us the same kind of result and the result object back the way we always saw. So session execute, just like connection execute, still sends you back a result. Let's see what kind of result it is. It's a cursor result because this was a very raw core statement that just ran, and it gave us a cursor result back. But the session can give us other kinds of results back as well when we do more ORM-ish things, and I'll hopefully get to that before we run out of time in 10 minutes. So to end the transaction that the session's in, we call session.commit or session.rollback or session.close. So here we're doing session.close, which will do the rollback thing. Yep, we'll do the rollback thing. And that rolls back. That's just like connection.close. And again, as I spent all that time on context managers in the engine chapter, the same patterns apply to the session. Session maker and session integrate together to provide context manager support that is trying to be equivalent to how the engine connection work. So that it's the same idea. You don't have to change your mental paradigm. So here we open a session, run a statement in a block, and then the session is closed, just like with engine. This is just like with engine.connect. With session factory, a session. Session execute a statement and give us all the results in a list. We run that and we get nothing because we didn't put any data in yet. This is the part of the talk where I start talking more quickly because I want to get to a certain thing in the talk before we end. So forgive me if I talk a little fast. I think we will do question and answer after. I'll be on Slack, coughing my brains out, but you won't know that. So let me just whip through the last of this and then we do the more questions on Slack. Session maker and session support the same transactional patterns as engine connection. Commit as you go is there. So with session factory, okay, run an insert. You can run an insert with session. Commit the code. We just put some data in, by the way. Run that. Commit the transaction. There's also the begin once pattern where you can say a session make session maker dot begin, and then what we're going to run here is a delete statement that wants to delete the rows I just put in because I don't want to have them there. I'm going to put them in another way. Delete the rows. Commit. So those are the two transactional patterns of session. You have to use them. Real world code, try to use context manager patterns, as I've just shown you, to manage the session scope. However, for the purposes of example coming up now, when I show you what's called the unit of work pattern, we're going to make a single session and leave it opened so that the interactions can be seen, because with Python context managers, they don't show you this console will not show you the data until I finish the block. So I'm going to run a session, I'm going to keep it opened and not use the context manager. But I want to make clear, this is the session that we will keep open for the purposes of example. This is not the pattern you want to use. You want to have a context manager as much as possible and not rely upon, oh, we'll close the session later. No, know how you're going to close it right now. So keep the above in mind as we continue. And here's our session that we're going to just keep opened in a transaction, which is usually bad news. So recall the user that we made. There's SpongeBob, the stateful instance of a user. We want to persist it in a new row in the user account database table. We tell the session this is what we want to do using session.add. Session.add SpongeBob. And as is customary in SQLAlchemy, again, nothing happens. Okay, so what happened is the object is now referred to as a pending object, which means this is a Python object that we'll use to populate an insert statement. We could see the pending objects looking in a collection in session called .new. And there's the SpongeBob object in the .new collection. So the session knows that it wants to emit an insert statement for this pending object, but when will it do it? The session emits these insert and also updates and deletes for other operations for objects in a process known as the flush. And this pattern in the bigger sense is known as the unit of work, meaning the session will accumulate commands, and then when it needs to talk to the database to give you more data, it will flush out everything that it has pending first. Flush occurs when we run session execute or similar to get a statement. When an ORM instance runs a process known as lazy loading that we won't be showing too much here. When we run an explicit session flush method that we don't normally need to use, but once in a while if we need to know the value of a new server default. And also when we commit the transaction before the commit occurs, it will do a flush. So let's see what the flush looks like. We're going to ask the session to select rows from the user table. Before we do that, it will flush out the changes to the current transaction, and then it will run a select for us to get rows back, which will actually be pulling from that data that we just flushed. So it's a little bit of a multiple things happening at once thing here. It will persist the pending object and load it back in one step. So we use select to select rows, and we will select a user class without asking it for columns. When we select from a class and we send it with session execute and not connection execute, we will get our ORM objects back within the row. We won't get columns. It'll actually put it all into an object for us in kind of a hierarchical result row. So here we have select users where name is SpongeBob. There's no actual data in the database yet, but when we run it, the flush will happen. So the transaction begins, the insert ran, the flush occurred, and then the data went in, and then we selected it, and it asked for SpongeBob, and we got a result back. Now, what's in that result? It has a single row. And within this row is the user we selected as a single column value, which seems a little weird. And I'll show you the row. Here. There's the row. And we can see it's a tuple with this fully constructed user object inside of it, which seems pretty awesome. And let's assign that this will be easier to remember. Also, SpongeBob will be assigned to that object. Okay. we can see that the server generated attributes, ID and created at, were generated by SQLite. So not just created, but also the primary key. And those got populated for us, which is pretty handy. And there's the object. And another funny thing that happened is that the object that we just got back from the result is actually the same Python object in memory as the one we used with session add, which is weird. So SpongeBob is the object that we created, which also seems to have its state updated. And then the one we got back looks the same, and they're actually the same object, which, if you haven't used SQLAlchemy before, might be weird. The way that happened is because the session uses N, and if I had people actually in a room with me, I would be doing the clapping the hands, I'll follow repeat, but we went to a class called the identity map. So there's this thing called the identity map. What's that? It's a so-called weak mapping, meaning that the objects in it are transitory as far as Python garbage collection is concerned, of objects key to their class and primary key identity. So we can look at the identity map using a dictionary on top of this attribute called identity map. The identity key is this thing here. It's the class and the primary key and some supplementary stuff we're not using, linked to the user object. So there's only one user object happening here. We inserted, we selected, it's the same object over and over again. All the objects that are persisted by the session using flush, as well as objects that we load with execute and scalars, whatever, are placed in the identity map. So when an object is in the identity map, it is no longer known as pending, it's now known as persistent. So persistent objects means that there is a row in the current database transaction that matches this object's primary key identity. That's the definition of persistent. Whereas pending means this row will be inserted. Persistent means this row has been inserted at some point, either now or previously. So the identity map is a very important integration point because just for now, it just was able to populate the object we already gave it, and we could only have that one object, and we don't have multiple copies of SpongeBob floating around confusing things. So quickly, before I have like 2 minutes left, we had to extract the user object from a row, which was inconvenient, that we want objects back. We don't like rows anymore. I mean, we like rows, but we don't want them now. We want objects back. We're normally going to use a method called session.scalars, which is like that result, that scalars method I showed you earlier, which will return just the first object of the first row back instead of rows. So this is all for consistency. Execute everywhere always gives you a result that always returns rows. Scalars everywhere always gives you a result that returns Python objects that are the first column. You actually get other columns too, but usually the first column. So for everyday ORM load objects, you want to use session.scalars. And that's what's in a lot of the documentation examples. So here, we'll run it again. We'll say session.scalars statement, select user where name is SpongeBob. And then from the scalar result set, give us the first Python object. And then we get another value that we will assign to this too as SpongeBob, which is the same object again. And you get it back, you get that same object back. Even though SQLAlchemy ran the select statement, as it ran the statement and got the results, it saw that this particular primary key identity was already in our identity map, and it used that object again. Is there a last? No, because last is not easy, because to get a last without doing an order by, you have to run the entire result set all the way through. And SQLAlchemy tries to not trap you into situations where you're going to pull the whole result and throw it away. That's kind of always a big gotcha. So you would, to get a last, you would do order by something in reverse and get first. That makes sense. Again, you need to know a SQL. So we have 1 minute left. That's really all I have. The last thing I can show you is add all that will add some more objects, and it does pending changes. So there's no time. It will modify. We can modify attributes. The objects become what we call dirty, and I'll get to the flush part where it will update a dirty column and then also insert some more pending rows. And there's a whole lot more to talk about the unit of work, but that's all we had time for in this talk. And then also chapter 6 in here talks about ORM relationships, one to many, many to one. And if you're new, it's good stuff. And also the tutorial online has got great stuff. I'm going to skip this part because that's in the talk too. Controversy. There we go. We're at the end.